Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is lecture number 23 in which I will explain you electronic transition N to pi star. Okay, so N to pi star transition. When heteroatoms like oxygen, nitrogen, sulfur, etc. is present in organic compound having pi bond between heteroatom and carbon. Then molecule has pi BMO, pi star ABMO, and n orbitals. These are found in molecule. Among this, the order of energy level is pi BMO less than n orbital less than pi star ABMO. That means energy gap between n orbital and pi star ABMO orbital is minimum, and energy required for N to pi star transition is also minimum. So that when UV visible radiations of higher wavelength is absorbed, N to pi star transition is observed. Occur. Okay. Normally, carbonyl compounds that is C double bond O with pi bond that is C double bond C in conjugation show N to pi star transition. Let us see the figure, which we draw like this. Carbon double bond O. Oxygen has two lone pair of electrons. Now, when radiations of greater than 200 nanometer is absorbed by this electron, then N to pi star transition occur, in which electron from N bonding orbital transferred to pi star orbital, and this is called N to pi star transition. With orbitals figured, see this one, carbon and oxygen have pi bond, sigma bond. There are two pi electrons in carbon and oxygen. These are pi star orbitals. This is pi orbital, and oxygen has two lone pair of electrons in two non-bonding orbitals, n orbital. This is also an n orbital. This is pi star orbital. Now, one of this n electron will move to pi star. This is pi orbital electron. Now, one of this n bonding electron will go to pi star orbital. Now, here you can see that the plane of n orbital and pi star orbitals are different. So here transition occur from one plane to another plane. Only one electron left over here and one electron transfer to pi star orbital. Okay, so this is called N to pi star transition, and here symmetry changes. Why? Because electron changes the orbital plane. Okay, so this kind of transition is also known as forbidden transition, where symmetry changes, orbital changes, orbital's plane changes. That is why. So N to pi star transition is called forbidden transitions because of this reason. Now, this type of transition, N to pi star transition, requires low amount of energy and symmetry of orbitals changes, because n orbital and pi star orbital are not on the same axis. So it is known as forbidden transition. I will explain you in detail what is forbidden and allowed transition in next lecture. And therefore, it is also having low intensity transition. or low probability transition. So that the value of epsilon, that is molar extinction coefficient, would be less than 10 raised to 3. Let us see some example like C double bond O. If one of the bond of carbon is with hydrogen, then we call it aldehyde. The lambda maxima of this would be 200 nanometer or nearly 200 nanometer. When both are alkyl groups, then we call it ketone, and absorption is about 280 nanometer. And if it is OH group, one of the group attached to carbon is OH, then absorption is nearly 205 nanometer. So this way you will find variation in N2 pi star transition. Now if we take this example, HCO, single bond CH, double bond CH2, then we have C double bond O as well as C double bond C. So this is known as enone system. Okay, it is called enone system, and absorption is about 207 nanometer because the hydrogen carbonyl group has hydrogen over here. Now, in case of more conjugation to the system like CH, double bond CH, and we will put one more pair of carbon with C double bond C, then one more conjugation is there, so wavelength will be little bit more, that is 237 nanometer. So this way absorption of this will be around 200 nanometer because it is aldehyde. If you increase more number of C double bond C groups, then obviously the value of absorption will be little bit higher. But in any case, these all compounds are colorless because they have lower molar absorptivity. Okay, so that's it about N2 pi star transition in this lecture. Thank you so much.